Hello friends, welcome to Chella's Kattunar, and we have already successfully studied the define phase. So now we are entering into measure phase. So in the measure phase, the first lesson will be measurement system analysis. So let us go into the topic. What is the measurement? So measurement process is the method in which units are measured and collected through an instrument. So it can be used further for an analysis or conclusion. So why it is so important? So error in the measurement can lead to a wrong decision. If we are actually having a weight of 60 kg, but your measurement system is having error and it is showing a 70 kg, it will create a confusion, and you will start to do some weight reduction, or you will start to you will stop eating good things. So this error can lead to a confusion, a wrong decision. Same way, second one is selection of an instrument is very important in the measurement system. So like normally there is a thumb rule. So least count of instrument should be less than or equal to the 1/10 of your tolerances. So for example, tolerance of outer diameter is 50 microns. So least count of the instrument what you are going to take for measuring that particular parameter should be minimum 5 microns or less than that. Normally we have a 2 micron or 1 micron instrument. So we use that instrument, that 1 micron least count instrument for measuring this outer diameter. So the least count of instrument should be less than or equal 1/10 of a tolerance of a parameter. So let us learn measurement basics and few terminologies. First one is accuracy. So it is the closeness to the reference. So the reference, if you are just measuring a parameter, that reference value is 5 mm, and if you are taking 5 readings and each reading how much close to the reference value, that is called accuracy. If it is less gap and it's very close to a reference value, then each and every measurement value and that method is accurate. This is called degree of conformity. And second one is precision. So it is the closeness of repeated measurements is called degree of repeatability also. Because if you are taking 10 readings, so how much each and every reading is close to each other, that is called precision. If variation is more, that means your precision is not good. So let us have some examples below. So you just imagine the true value is 5, the actual standard value is 5, but the area starts from 1 to 10, you can imagine it's mm. So if you are measuring multiple times, these black spots are measurement values, actual values, whatever observed during measurement. So if you see just multiple measurements have been taken, so that has been plotted in the graph wave. So all the readings are lying between 7 to 9. That means the values between each and every measurements are nearby. This is precision, but it is not accurate because the true value is very away from the actual readings. It is not nearer to the true or standard value, but each and every readings between measurements are when variation is very less, so it is precision but not accurate. Second, coming to second image, you can see each and every reading is equally distant and very nearby to the standard value. But comparing to the standard value distance, so distance between each and every reading, that is differing, and it is just away from each and everything. So this is accurate but not precision. And third one is, you can see this image. So each and every readings whatever taken through the measurement system, so completely away from the standard value, that is a sender, as well as the distance between each and every individual readings are also very far, very high. So this is neither accurate nor precision. And coming to the final point, you can see all the readings are close to the target, that is standard value, as well as the distance between each other is also very less. So the error of precision and accurate is completely nil here. So this is good, accurate as well as precision. Friends, let us learn about types of data, because we should know which type of data we are going to collect for our analysis or measurement. So based on that only we will select the measurement system, and accordingly we will plan for a error evaluation, and if error is less, that instrument and that method can be used for a measurement. Otherwise we have to improve that measurement. So first let us understand four types of data basically. One set of data are quantitative, second one is qualitative. So quantitative, it will be measured and represented in the numbers. So there are two types of quantitative data. One is discrete, second one is continuous. Discrete, that numbers cannot be break down, it's a completely full numbers like count 1, 2, 3, such a numbers will be there in the discrete data. Second one is a continuous data, that numbers can be broken down further. So you can, in that category you will have two types. One is interval, so that numbers can be broken, but the difference it will be a known difference, like time, it will be broken as each 1 minute and 5 minutes, such a way it will be broken. The differences between the numbers will be known to each other. Here second one is a ratio, so that will be having a measurable intervals, so that can be determined, but that is not known one, that can be determined further, so like height, weight, etc. So second category of data are qualitative. So there we have two types, nominal, ordinal. Nominal is having a naming variables like colors, brands, etc. So the ordinal, that will be it's also qualitative. There is no numbers or no measure continuous scale here, but it will be in the order form, like 1 is happy, 2 is neutral, 3 is unhappy, such a way it is in the order form. So that is what it is called ordinal. So for example, you might have just went through a surveys, there you might have seen they strongly disagree, neutral, agree, strongly agree, such a order wise data. So that is called ordinal data. So now let us understand the measurement system error. Like in the first slide already we have studied, the measurement system if is having error, so it will lead to a wrong perception and wrong decision. So we should understand the error first. So like here you can see the image, like operator who is measuring the particular item or parameter, and the reference and the procedure, how he is following the method measuring process, that is procedure, and which equipment he is using and which environment it is being used. So all these 5 things are affecting a measurement. So that item is just taken for a measurement. So by considering all these factors, so the measurement will be coming out. So any of these one may affect the measurement process. So that will lead to the wrong measurement coming out of the process. So how to evaluate this error and how to eliminate? So let us study further. So measurement system analysis is the chapter, it's a complete area where we are analyzing our measurement system and understanding the error, category of error, and taking a decisions to go ahead with the same measurement or not. So there are 5 types of error. Just 3 are under the category of accurate. So bias, linearity, stability. Bias, again the variation between the observed range of observed average to the reference value. So now like 5 mm is your reference value, you are taking 5 using an instrument, you are taking 10 readings, and the average of that is coming at 5.2, that means 0.2 mm variation, that is called bias of particular instrument. So second one is the linearity. So bias over the measurement range is called linearity. Like we have seen 5 mm, 0.2 was the bias error. So the same instrument is used to check the 10 mm, 15 mm, 20 mm all across the range of the instrument. So each and every stage that bias value has been noted, and that is further calculated to the linearity, that is graphed and it is calculated further. And stability is bias over time. Same 5 mm reference parameter is taken in the morning, evening, night. So circumstance and environment affect in some few cases. So that is called stability. Bias over time is called stability. So these accuracy errors are majorly covered through calibration process. So normally whenever we are going for any measurement system, so first of all the instrument should be calibrated. So if it is calibrated, these errors will not be there. So we want to understand only the basics of these errors. So we are not going to do any studies or any practice on this accuracy errors. So we will be focusing on more precision errors. So that may not be captured in the calibration. So this thing will be studying in the next lesson in depth. First, let us understand what is meant by repeatability and reproducibility. So repeatability is a variation in the measurement obtained by a one instrument used by the same operator for measuring a parameter for multiple times. A single operator, if he is checking a single parameter for multiple times, so the values observed in multiple times, and the variations observed between the values of multiple times is called repeatability error. And the same way, if with the same parameter with the same instrument, multiple operators, multiple persons are verifying multiple times, so that variation between the operator A to B to C, that is called reproducibility error. So let us understand in the next lesson in detail about GR&R, gauge, repeatability and reproducibility error, and how we are going to evaluate and how we are going to address it. Friends, thanks for watching. Hope you got basics about measurement system analysis. And please mention your comments in the comment section so that I can cover that topic in the forthcoming videos. Thank you.